Hello, good evening. I'm going to discuss about the topic Bayesian classification. First, what is Bayesian classification? Bayesian classification in data mining is a statistical approach to data classifications that uses Bayesian theorem to make predictions about a class of a data point based on observed data. It is popular data mining and machine learning techniques for modeling the probability of certain outcomes and making predictions based on that probability. Bayesian classification is a powerful tool for data mining and machine learning and is widely used in many applications such as spam filtering, text filtering, and then text classifications and medical diagnostics. Its ability to incorporate prior knowledge and uncertainty makes it well unsuited for real world problems where data is incomplete or noisy and accurate predictions are critical. Next, the basic idea behind Bayesian classification is data mining is to assign a class label to a new data instance based on the probability that it belongs to a particular class given the observed data. Bayesian theorem provides a way to compute this probability by multiplying the prior probability of the class based on previous knowledge or assumption by the likelihood of the observed data given that class. Several types of Bayesian classifiers exist, such as SNES-based Bayesian network classifiers, Bayesian logistic regression, etc. The Bayesian classification is preferred in many applications because it allows for the incorporations of new data and the probabilities of class labels accordingly. Next, what is Bayesian theorem in data mining? Bayesian theorem is used in Bayesian's classifications in data mining, which is a techniques for predicting the class labels of a new instance based on the probabilities of different class labels and the observed features of the instance. In data mining, Bayesian theorem is used to compute the probability of a hypothesis given some observed event, a set of features and or attributes. It is named after Rivers and Thomas Bayesian, an 18th century British mathematician who first formulated it. Next, Bayesian theorem states that the probability of hypothesis H given some observed events E is proportionally to the likelihood of a evidence given the hypothesis multiplied by the prior probability of the hypothesis as given below. That is P of H by E is equal to P of E by H into P of H by P of E. Now P of H by E is a posterior probability of the hypothesis given the event E, and E by H is the likelihood of conditional probability of E1 given by the hypothesis. P of H is the prior probability of the hypothesis, and P of E is the probability of the event. Next, what is prior probability? Prior probability is a term used in a probability theory and statistics that refers to the probability of a hypothesis or even before event or data is considered. It represents our prior beliefs or expectations about the likelihood of a hypothesis or even based on previous knowledge or assumptions. For example, we are interested in the probability of certain diseases in the population. Our prior probability might be based on previous studies or epidemiological data and might be relatively low if the disease is rare. As we collect the data from medical tests or patient symptoms, we can update the probability estimate by Bayesian theorem to reflect the new evidence. What is posterior probability is a term used in Bayesian inference to refer to the updated probability of hypothesis given some observed event or data. It is calculated using Bayesian theorem, which combine the prior probability of a hypothesis with the likelihood of an event to produce an updated or posterior probability. And it is important to the Bayesian inference because it reflects the latest information about the hypothesis based on the observed data. It can be used to make decisions or predictions or updated further as new data become available. Next, what are the applications we are using in Bayesian theorem is has a wide range of applications in many fields including statistics, machine learning, artificial intelligence, natural language processing, medical diagnosis, image and speech recognition and more. Here are some examples of it application such as spam filtering. Spam filtering is where it helps to identify emails that are likely to be spam based on the text content and other features. Next is medical diagnostics. Medical conditions based on observed symptoms take results and prior knowledge about the prevalence and characteristics of the disease. Next, risk assessment. Risk assessment is such as accident, natural disasters, or financial market fluctuation based on historical data and Other relevant factors: natural language processing to classify documents, sentiment analysis, and topic modeling in natural processing applications. Next is recommendation systems like e-commerce websites to suggest products or services to users based on their previous behaviors and preferences. Fraud detections. Bayesian theorem can be used to detect fraud behavior such as credit cards or insurance fraud by analyzing patterns of transactions. Thank you.